I'm going to be discussing the second type of reaction that we're going to be looking at in this unit, and it's decomposition. So right here on my left-hand side, I have the helpful kind of recipe that you guys have on your sheet right in front of you. And remember, this is from page 10 of your packet. All right, and you guys are going to have this on the test, so make sure you're using this and are comfortable using it. You don't have to memorize it. All right, which is a gift. Most chemistry classes have to memorize it, and in AP you definitely will, but in this class I'm not going to make you memorize it. I just want you to be able to predict the products of these reactions and be comfortable with all of these different types of decomposition reactions. So in decomposition, it's really going to be like a little a recipe. So let's go through and review some things that we actually already talked about in synthesis, but let's look at it again. All right, so some terms we're going to be using again, just as a review. A metal stands, M stands for a metal. All right, and NM stands for a nonmetal. We're going to be seeing that again and again, and you actually can see that right over here in our little table here. You've got NM here saying that this is going to be a nonmetal oxide. Here you've got a metal oxide. So just be careful with that. We'll be talking about when we use each of those. We'll look at them in all of these examples below. All right. Now, the question you should be asking, you have a whole list on your cheat sheet that I gave you and what you have in front of you. How do you know when you have a decomposition reaction? Because in these problems you know because you're in the decomposition section. But if I were to mix up these problems, which I will eventually do, how do you know that you have a decomposition reaction? Well, what you can do is look at how many reactants you had. So with synthesis, you had two reactants. You had two elements. While for decomposition, if you notice, each of these, you always just have one reactant. So in decomposition reactions, you're always just going to have one reactant. And then for decomposition, if you notice, for the most part, you're going to have 1, 2, 1, 2. Here's a funky one, you have 3, but 1, 2, 1, 2, 1, 2. You're going to have 2 or 3 products. While for in synthesis, you always have one product. So there's one really easy way to distinguish between synthesis and decomposition, since those are the only two that we've looked at, the only two types of reactions that we've looked at in detail. Okay? If you have one reactant, you automatically know it's going to be decomposition. If you have 2 elements, you automatically know it's going to be synthesis. All right. So what we're going to do right now, we're going to look at a couple of these together and predict our products. All right. So let's look at this first example. Just like before, I give you different types of decomposition reactions. So our first job is to determine what type of reaction we have here. So I give you CaCl2. All right, so let's look through it. What I would recommend, A is kind of your go-to if none of B through F work out. So let's look through B through F, see if this applies. If it doesn't, then you'll go with A. All right, so let's look at B. You have a metal and a carbonate, CO3. And you don't have that here. You don't have carbonate. You do have a metal, but that's obviously not carbonate. So B doesn't work here. Let's look at C. Metal HCO3. Well, no, you don't have that. So I'm hoping this is pretty obvious that you don't have 2C. Let's look at MOH. Do you have a hydroxide right after your metal? No, you do not. All right. Do you have M after your metal? Do you have ClO3? No, you don't. You just have Cl2. All right, so E doesn't work either. And then finally, F for an acid. In order to have an acid, you would have an H out front, which you don't. So once you've gone through B through F and realize that none of those apply, then you can go to A and say, okay, my reaction is a 2A reaction. All right, and then you need to make your products. Okay, so this is basically the exact opposite of synthesis. So what you're going to do is A is going to be Ca, B is going to be Cl. All right, so ignore your subscripts. All right, what you're going to be doing is just writing out the identity of each element. Okay, so A is Ca, so I'm going to write Ca here. So here's Ca. All right, plus Cl. Okay. Now, I would be done, okay, and I followed this formula to a T. The only issue is, if you remember, Cl is one of your diatomic elements. So I'm going to write a 2 here, not because there's a 2 here, but because Cl is a diatomic element. So I'm going to put a 2 here. All right, and I'm done. So I've taken one compound, I've broken it up, I've decomposed it into Ca and Cl2. All right? Cool. Let's go to the next one, which I think is a good example of a different type of decomposition reaction. I have LiOH. So let's go through these. Remember, skip A until the B through F don't apply, and then you can go to A. So do you have a metal with a carbonate? No, I do not. Metal with HCO3? No, I do not. Do I have a metal with hydroxide? Yes, I do. Lithium is a metal, and I have OH right behind it. So ignore the is heated part. For decomposition, guys, in order for decomposition to happen, you have to heat something. So that's what the heated part is. All right, so I have a metal hydroxide, and what that gives me is a metal oxide plus water. All right, so one of my products I know is going to be water. So I'm going to just write out water. Now, the order in which I write my products really doesn't matter. All right, so I'm going to write water first, and then I have a metal oxide. So as soon as you say MO, all right, I know I have lithium as my metal in this problem. Okay, you should automatically in your head be saying, when I make my compound, since lithium is a metal and oxygen is a non-metal, I need to cross my charges. All right, so I'm not going to do this in the actual problem. I'm going to do this off to the side for people who are still having issues with it. And if you're still having issues with this, guys, you need to be watching my video on how to make compounds. All right, because you're going to be really struggling soon. All right, so lithium has a +1 charge. Oxygen has a 2- charge. All right, and so to make this compound, since this is my metal, this is my oxide, I'm just going to cross my charges, and so I get Li2O. So my second product is going to be Li2O. That's my metal, my metal oxide, and I'm done. All right? So not too bad. Oh, and this is a 2D reaction. Okay? So as I told you guys, if you are able to, this is the hardest part of it once you've recognized what type of reaction it is. In classes, a lot of teachers make you memorize these. In an AP, you'll have to memorize these types of reactions, which makes it a lot more challenging. For us, you have to recognize what it is, and then I give it to you on the test. I'm going to give you all of this so you don't have to memorize it. But you do have to be able to cross your charges, and you do have to be able to identify what type of reaction you have. So you need to be able to make sure you're using your head and don't just, guess around. All right? So I'm going to have us go off, and I'm going to have us do, I'm going to have us do 2 more together, and then I'm going to have you guys complete the rest. All right, so we're going to do 4 quickly. We're going to skip 3. You can do 3 already. Okay. 4, I have Mg and CO3. All right, so let's look through it. Skip A. Let's look at B. Do I have a metal and carbonate? Well, yeah, Mg is a metal, and I have CO3 right behind it. So my reaction, this is a 2B reaction. Awesome. All right, and so one of my products I automatically know is going to be CO2. That doesn't change no matter what metal I have. So I'm going to write that out first because that's always the same. And then I have a metal oxide. All right, now as soon as you see a metal oxide, you need to be crossing your charges. So I'm going to cross my charges over here. Mg has a 2+ charge. Oops. Oxygen has a 2- charge. If you can do this in your head already, fabulous. Okay, and what you should be recognizing is the fact that these 2's are going to cancel. All right, and so my other product is going to just be MgO. All right. So I think it's very doable. The issue is being able to recognize what type of reaction you have and then being able to cross your charges. All right, so obviously I promise you can have plenty of practice. We'll do a lab with it and everything. All right, so let's do one more. Let's have, actually we're going to do, Yeah, we're going to just do one more. So let's do number 5 together, all right? So if you look at number 5, I've got LiClO3. So go skip number 2A. Okay. Do I have a metal carbonate? Well, no, I don't. Do I have a metal with HCO3? No, I do not. Do I have a metal with hydroxide? No. Metal with ClO3? Oh, look at that, I do. So it's going to be a 2E reaction. All right. And then my products are going to be O2. So I'm going to write that first. Okay. Plus, now, I need to make a metal with just Cl, with chloride. So once again, because Cl is a nonmetal and lithium is a metal, I need to cross my charges. So here's Li with a +1 charge. Here's Cl with a -1 charge. Cross my charges, and you just get LiCl. All right. So I think these are pretty reasonable. So I'm going to leave it at that. What I would like you guys to do right now, I'm going to just have you complete number 3, 6, 7, and 8. In the interest of time, I'm just going to have you do those, 3, 6, 7, and 8. We'll do number 9 and more practice in class. Since we haven't talked about F yet, I wanted to talk about it with you guys. So just do 3, 6, 7, and 8, and then you're done with your homework. The one thing I do want you to go do, since I didn't do it, I'm sorry, but I want to make sure you guys are comfortable doing it. Go through each of these reactions once you've done 3, 6, 7, and 8, and make sure each of these reactions are balanced, because they might not be. Okay, so go through and make sure and balance them if they're not balanced, all right? And that is the end of the decomposition video.